Hi, this is Ann Cordy, and this is the job element method. The job element method is the earliest sort of worker-oriented methods, and it was developed in the 1950s by Ernest Primoff along with the U.S. Civil Service Commission. The definition of an element is that it's a combination of behaviors and associated evidences. Recall that we read about an element in the first chapter that is the smallest unit of work with a beginning, middle, and end. An element here is a similar concept. This is most similar to the work-oriented methods because it focuses on work behaviors and the results of the behaviors rather than something abstract. They have a naming convention. Instead of using terms common to psychologists, elements are named using terms more commonly found in the workplace. An example of that is the behavior of acting in a dependable fashion, evidenced by punctuality, accommodations for dependability, and a record of doing exactly what is required by the job is an element termed reliability. The contents of elements. The elements have a broad range of behaviors that are categorized into three types. Cognitive elements, which is using the brain, but recognizing tools and their uses, reading blueprints, or computing statistical equations. You have psychomotor elements, using your body, which is sensory and perception, like colors or sounds, carrying out simple to complex motor skills, like operating a drill. And you also have work habits, which is using your character. It's more motivational behavior, such as willingness to take on more work, make sure the job is done perfectly, and meeting deadlines. The steps in the job element method are to gather elements from subject matter experts, have the experts rate each element on 4 scales, derive a scale value from the expert ratings, share derived ratings for experts, and use results in your application, like developing a test. So the first step is to gather information. There's 2 sessions that take 3 to 5 hours each. The first session, the SMEs brainstorm and rate a list of elements. The analyst helps prompt the SMEs when they seem to run out of ideas, like what might make you want to fire someone, what might cause trouble. Once the elements are listed, each one is broken down into sub-elements which help illustrate the meaning of the element. The analyst takes this list and compiles the elements, gives their ranks, and analyzes the data. In the second session, they use the work done in the first session for a purpose, such as developing a test or training program. The rating scales, this is where it gets a little bit confusing, so bear with me. The rating scales, there are 4 separate scales. So it's not one scale with these 4 values, it's each one of these is a specific scale. So the barely acceptable scale is each rating scale has a 3-category response. A 0 if the scale has minimal value, a check mark if the scale applies somewhat, and a plus sign if the scale is highly applicable. For the barely acceptable scale, it rates a 0 if no workers possess the elements. It's a check mark if some workers possess the element, and a plus if all of the barely acceptable workers do. For the superior scale, it's 0 if the element is not useful for distinguishing the superior worker. It's a check mark if the element is valuable for distinguishing the worker, and a plus sign if the element is very important. For the trouble likely if not considered scale, it's me. It's 0 if trouble is not likely on an element for new hires. It's a check mark if there is some trouble if the element is not considered on a screen for new hires, and a plus if the element must be tested for new hires. On the practical scale, it's a 0 if possession of the element will not fill any job openings, a check mark if it will fill some openings, and a plus if the element would fill all openings. The example that the book uses is talking about breathing. If we consider the element breathing for most jobs, all barely acceptable workers would have this element, and the SMEs would assign a plus to this element. For the superior scale, if the superior workers all breathe, but breathing does not result in a reward for superior work, it doesn't distinguish them, the SMEs would assign a 0 to this element. In the trouble not likely if not considered scale, breathing is safe to ignore. It's not going to need to be tested on an examination for new hires. On the practical scale, if breathing was one of the things required, then we would expect to fill all requirements or all openings after screening for it. So, on the derived scale, so the analyst takes the results from the reading scales and prepares them for the second session by converting the symbols to values. For anything that rates a 0, gets a 0. Anything that gets a check mark gets a 1. Anything with a plus sign gets a 2. So here's an example of what the chart will look like after the items start receiving their value. Now, you can find this on page 68 of the Granite text. I've only copied over half of it just for ease of viewing. So the numbers in the columns for the B, S, T, and P, those 4 scales we just went over, are percentages of the max points from each scale. For example, if the max possible was 12, because you had 6 subject matter experts, and the sum of the smooth points was 6, you would get 50% in that column. So, the next column over is the TD column, which is total value. Total value is the value of the element in determining abilities of job applicants. The formulas here, TB equals S minus B minus P plus SP plus T. So you would take the values that you have in the chart and plug them into this formula to get a total value. It helps you select for elements that pick superior workers and reject those who do problems, and not select the elements that are too common or uncommon. The exception to this chart, all of these are percentages except for the total value column. That actually is just a number because it's the addition of the percentages, and the max value of TD scores are 150, but 100 and above are significant and define true elements. The item index is how much a sub-element is important in the context of the test. The item index equals SP plus T. It's the second part of the TD equation, which makes sure that you do not select for uncommon or too common elements. This is also a percentage and can be used to rank applicants if it's a value of over 50%. The training value is the value of the element in training. And the formula for that is TR equals S plus T plus S times P minus B. And that's little asterisk over the P is the reverse of P, because they want to make sure that if all openings can be filled by all applicants, then P can equal 0. This formula means that we want to train people on skills that superior workers have and would be difficult if they were absent. But we only want to train if those skills aren't in the candidate pool already. I'm going to go back to this chart. You'll notice in parentheses there are different letters S, RS, SC, etc. This is the next step this is step 4, assigning elements to categories. So each value, E is element, it's marked in the total value of 100 or greater. S is significant sub-element, the pass gets marked when IT is 50% or greater. TS is training sub-element, and that ability gets marked when TR is 75 or greater. SC means screen out. It's a minimum requirement level, and it's marked when B and P are at least 75 and T is 50 or greater. Now remember, when I'm saying the letters, I'm talking about the column headings. So I could, B is, again, barely acceptable. P is practical, and so on. So RS is rankable screen out. If a sub-element meets the value for both S and SC, the sub-element meets the minimum level for the job, but if it is above that value, it can be used to rank applicants, according to who to hire and who not to hire. This whole process helps develop work sample tests and evaluate if tests aren't working, and the job needs to be re-examined. It's also used for choosing tests that were developed outside of the sample, outside of the analysis. The J coefficient is something that Fermat developed. It was never widely adopted. It's an estimate of the validity coefficient if we were to conduct a correlation study, like test aptitude to overall job performance. There's 3 pieces of information that's needed to calculate the J coefficient. The correlation of job elements with overall job performance, the correlations of tests with job elements, and the correlations of the job elements amongst themselves. It was proposed that the SMEs could estimate the first point, the correlations of job elements with overall job performance, but the other 2 needed to be developed over years of research and compiled, where the accuracy would only increase over time. Given several tests for job applicants, one could compute the J coefficient for each and use the test with the largest J coefficient as the best test for the applicants. Krimov suggested using more mathematics and empirical evidence to calculate the J coefficient, but later researchers have compared several human methods for computing the J coefficient and found a high level of validity for a person to select the most valid test for the job rather than required on the empirical evidence. The advantages to the job element method is that it's deliberately circular. An ability is defined to be whatever is needed to complete the task. It's very concrete. There's a focus on observable behavior, which is easier to track. Aspects of this method can be found in other methods, so it's tried and true and has been developed in addition in future methods. It also brought knowledge, skills, abilities, and other characteristics into the lesson method. Disadvantages: it cannot handle abstract concepts such as perceptual speed and verbal reasoning. The focus on observable behavior might lead to ignoring potentially valid tests that are more cognitive in nature. The complex rating systems can be a little mind-boggling, and they're not always necessary to choose the best applicant for the job. The heavy reliance on subject matter experts could be the tools that could cause legal issues. In summary, the job element method is something that could be very useful, but might be too complex, following all the multiple steps to calculate the perfect total value for a job element.